beautiful day today, and we'll be taking CO2 flux measurements. So in my hand I have a portable greenhouse gas analyzer from ADC, and this, as you can see from the screen, gives us our CO2 measurement in part per millions. Usually takes about 10 to 15 minutes to warm up depending on the brand, and that's what you power up first. This is the spot where we'll be taking our flux measurements, and you typically have your collars installed 24 to 48 hours before you take a reading to keep the area stable. We have different types of chambers. Today this is the chamber we'll be working with. This was built in the lab for site measurements on campus. You can have them as large as 60 by 60 based on how much vegetation you want to cover in your flux reading. Connected to this chamber would be tubes for our inlet and outlet points, and so these would go right into the IRGA to give us the CO2 coming out from the plant production. We'll use a clear chamber for light measurements, and then we'll be taking dark measurements. We'll have a shroud or a tarp going over to give us that dark measurement where we only have readings in respiration. And the difference between the light and dark measurements will be what the actual productivity of the plants is. In the chamber you have a fan which improves circulation so you don't have biased readings. We also have a soil probe which will be giving us the soil temperature up to a depth of 20 centimeters. So we have the quantum flux meter by apogee, and this is what gives us our measurement, telling us the amount of sunlight hitting our chamber. You also work with a water bottle, and in here the water goes into the collar so that you have a tight gas seal when the chamber is put on. And then you work with a stopwatch where you take your readings every 2 minutes. This is what the sample data sheet looks like, giving you the time every 15 seconds plus your CO2, your power, your relative humidity, and then the temperature in degrees Celsius. You fill this out for every plot where you take readings, and then you compute to calculate your productivity for the site. So now to get the setup running, you have your chamber, you attach your 9 volts battery to get the inner fans running. This ensures you keep an even temperature in the chamber as well as even distribution of gases, so you don't get biased readings. Make sure to uncover your power sensor before you place on the chamber, and then you want to ensure all your tubes. Some sensors have a base which screw onto the chamber depending on the type you make. You want to make sure you have all your tubes going into the right spot. So you have the inlet and the outlet, gas out, gas in. You have a snug fit so you don't have gases escaping. At this point, the IRGA is picking up the ambient concentration for CO2, which is reading at about 304 ppm and rising. You want to connect your reader to the thermocouple in the chamber, which gives you the inner temperature, and then you turn it on. You have all your instruments on and ready to go, and then you gently place the chamber over the collar without disturbing the setup. Ensure you capture all vegetation in your setup so it is more representative. At this point you get your timer to start running, and depending on the protocol you're running with, you're taking readings every 2 minutes, every 4, every 5 minutes. You're interested in putting the name of the plot, the dates the readings were taken, the time, and the researcher taking the data. You're also interested in the temperature profile at 2, 5, 10, 15, all the way to 30, close to your setup. And then on your data sheet you have the spot to put the CO2 in ppm for every point, be it 2, 4, 6, and 10, or whatever term you have on your data sheet. You repeat this process all through for the different times until your data sheet is filled for that plot. So as mentioned earlier, for CO2 readings, you need to get the light and the dark. For dark readings, you get a top going over your chamber. With the same setup, you don't need a power sensor this time because you're presuming there's no sunshine going into your setup. So you have a dark top or a shroud completely going over your chamber, and then you have the same tubes going in. Connected to the IRGA. You have your thermocouple giving you the interior temperature as well. Then gently place over your setup as you did before. Ensure the top or the shroud completely covers the chamber so you have no light going into the setup, because this would be your reading for respiration. The difference between the two readings presents your productivity. So you have your internal temperature reading, you start your timer, and then you proceed to take readings of the IRGA. As you can see, you have a lower CO2 reading than you did in the light. And you take this at the same time interval as stated on your data sheet. So at this point, you're interested in the CO2, you ignore the power since it's 0 for all of them, and then you take the interior temperature as well as taking the depth profile for the soil at the different levels as you recorded in your earlier measurements. The data from the dark and the light readings go on your data sheet, which you return to the lab to make your calculations to get your productivity.